Hello, everybody. Welcome back to SDEV 220. Still kind of just starting off tonight. And well, this week, this module, we're going to review the basic syntax or perhaps see it for the first time. I think everybody in here has seen some Python. When asked the question the other day, it seemed like everybody gave some sort of confirmation they've seen Python before. So just a quick review on the basic syntax, and then a few other things to talk about as we move into the more interesting things. That's the nice, one of the nicest aspects about everybody seeing Python before is that in this class, we can go a little further than we do in most of the 200 level classes, because there's we don't have to spend as much time on the language itself. Everybody's seen a little bit of it before, so just some extensions on that, and then we can start doing that software development part and see those other more powerful tools and more interesting things we can do. One difference from where you would have seen this before is in the 120, SDEV 120 and SDEV 140 class, there are certain things that are generalized, so they translate to other languages better, and might not necessarily be the most common way to do it in Python, or there'll be an easier way to do it in Python. So we'll see some of those. A few other things. Might take a first look at virtual environments tonight. Before long, we're going to have to do some stuff where we also have to do all the background setup for it, working in command line interface. So there's an assignment this week, just a fairly straightforward basic one, getting used to command prompt or command line or terminal. Whichever system you're on, it'll be the appropriate one for that. We might look at some of that this evening. Yeah, I guess we can jump in and start doing stuff. So one thing I want to talk about it's due with the homework this evening. And the part for the homework this evening will be really easy. Zoom just made the somebody joining call, but I don't see the buttons. I've stopped screen share. Oh, which by the way, you'll notice here in the middle of the room, I have my laptop set up. So if anybody wants to send me a direct message, make sure you send it to my laptop. It says Chris PC versus my actual account is over on the classroom computer. So if you send the DM to the classroom computer, I might not see that until the end of class when I go to log off the Zoom call. That's happened more than once. So whether I'm on my PC or Mac or Chromebook, it'll say Chris and then something in parentheses. So make sure any direct messages go to that, because that's the ones I'll actually see. Okay, I think everybody's in now. So that's weird. I don't know why the button wasn't up there whenever I had the screen share on. But so first off, okay, my Zoom buttons are doing weird things, getting in the way for a moment and like not going away. I can go to maybe this week's homework assignment, first homework assignment. Actually, any homework assignment, because I copied and pasted the same thing to put in all of them. So it has to do with those submission requirements. Which, if you haven't had me before, might be different than some of your other, what you would have seen in other instructors have. They'll basically just turn in the code and that's the end of it. But I usually ask for a little bit more than that. One thing that's going to be on all the submissions before those are due this evening at midnight, just make sure everybody's up there. Right, you turned in a GitHub URL. So for this evening, it'll be fine if you forgot something and need to re-upload that to GitHub. But we can roll back the clock on GitHub. That's one of the things we're going to look at tonight. It's the best place to look at the history. So don't think that's a way to get around deadlines. Like that end of semester deadline, I have seen that before. And when I go to grade it, I can roll it back to what was there by 11:59 p.m. at that deadline. And if I end up doing that, like there's something uploaded at 3 o'clock in the morning, and I roll it back, I'm not going to be in a very good mood when I create. That's the one that happened before. So it's not a way, being able to turn in that GitHub URL and then make changes afterwards isn't a good way to get around deadlines. But if you need to make changes, you've already turned in the one for tonight, but you forgot maybe the requirements portion of the manifest. You can still upload that, make changes up until that deadline. I can tell what was. I can roll back the history and see it there. But so there's a couple extra things. So the bug report is just a small. Well, you can take it further if you want, but a list of the bugs you encountered while you were making. Right, typos happen. Maybe something was wrong with the logic. But making just a little list of that. There's a couple of reasons for it. One is that standard that you may have heard from like a speech class. Preview what you're going to tell them the thing, and then review what you're going to tell them. That applies in learning as well. So seeing it 3 times, sort of preview like a textbook or something, lecture, then practicing the assignment, and then reflecting back one more time is beneficial for learning. So it does that. It also lets me know of any things that might be covered in more detail. So like if there's something that shows up on everybody's bug reports, that means I probably need to cover it in the lecture or be more thorough about what was going on with it. And it's also just good practice for software development field because we do more than just write code. There are some other little steps involved. So that's some of what's going on this evening stuff. Who did I just let in there? I named the list. Okay. That one. So there's the bug report, and you can do just a little bulleted list in a text file. Doesn't even have to be grammatically correct. That's fine. Or you can take it further, go look up a bug report template and fill one of those out every time. Or since we're using GitHub repositories to make the submissions, there is an issues tab there where you would actually go report bugs on a piece of software. So that would be a good place to do it too. And fill up the whole forum sort of thing. Somebody unmuted? Is that me that's unmuted? Oh, did you ask a question, Kyle? It sounded very
No, sorry.
Okay.
Other Kyle does have a question.
Oh, yes, what's that?
For GitHub sending you the URL, is there a specific place on GitHub that lets you send a URL, or do you just want to control copy the?
Just copy the address bar. That's one of the things that's going to show up in class tonight. So if we copy the address, we'll be on GitHub in just a minute. If we copy the address with the copy button, it has a file extension, it has a .git file extension. And that's what we use to work with it in our code. So for the web address, just copy and paste it from the address bar. Which will be the same thing if you copy that, but you don't need the file extension. You don't need the .git extension. So does that work for you, Kyle?
Yeah, that answers the question. Thank you.
Okay. So the bug report, if you can take it further, it's a bare minimum requirement, that one last reflection over what happened, hopefully avoid making similar mistakes in the future. Something's got to be there. If there were no problems at all, you didn't even make a typo when you did it, just write no bugs encountered, or just say there was no bugs, but something's got to be there. And the other one has to do with dependencies, which is part of a manifest. So a software is a very large thing, right? It's a big deal. There's lots of different stuff involved. If I go ahead and open up the terminal real quick. We saw pip, started looking at that last week for installer, but it does a lot of things. One of the commands we can put is freeze. So if I run pip freeze, this pulls out a list of everything installed on my default Python environment here that was not part of the default installation of Python. So I make a piece of software that requires Colorama that adds colors to the console. So if you get tired of printing in black and white or whatever color it is, and want to print out more colorful things. Kind of like emojis, you can change the color of the words and make it look nice, but not every console has colors. But when colors are allowed, it'll be there. Or pickling. So if I included that and or matplotlib, that's much more common to be included. If I included matplotlib, that's not part of the default installation of Python, but if the software depends on it, when I deliver that software to somebody, they probably need to make sure that matplotlib is installed on their computer. So we want to keep track of all those things. And you'll notice that when I pulled up this list, there's also equal to. So that says the version it is, and obviously greater or less than is adequate there too. So maybe if where's something with a higher number? Prompt toolkit. So on prompt toolkit, maybe I actually need the older version of prompt toolkit. Like this is the first one that they remove the feature that my software is using. So obviously then we could put less than 3. So prompt toolkit 1 or 2 would be adequate. Same thing for greater. If we know it's going to be updated soon, the equals is going to throw things off because pretty soon everybody's going to have version 4. So I think at this point in programming, everybody knows what less than or equal or if we say if we just put in the freeze command, we get this list of everything that's not part of the Python installation. There's a couple, and whenever we make a piece of software, we need to make sure it's going to run on everybody's computer. So another thing we'll be talking about probably Wednesday, virtual environments. That's something else we often do is it's very common to start from a completely blank version of Python. We don't have to reinstall it. We can make a virtual installation. And then we have a completely blank one, so we know exactly how that is configured in order to set that up. But we need that to be included. And this is something that's useful on GitHub, so I guess we can look at this here. Tonight's a review on syntax, and I'm almost positive everybody in here has seen some Python before, so I'm not in a rush to get to that. We'll look at some of the other things that we'll be needing. If we go in one of our repositories, which I created one for this, didn't I? I think I created one for this class.
You did?
I have a lot of repositories here. SDEV 220, oh, that was last year. SDEV 140, oh, there it is. Spring 2023. Yeah, so just the URL here is fine. Whenever we're going to go work with it, we want to use the copy button down here. And we go to the end of that line. You see that has the file extension. So if you want to, it's the exact same thing. You can just take off the file extension when you copy that. Then there's a copy button there available. Lots of different things. One of them has to do with insights. You come over here, you can see the traffic that's come to your site, things like that. Who's been on there, who's downloaded stuff, who's uploaded stuff, pushed and pulled things to and from the repository, the different traffic, see the history of all the commits. That's taken a long time to pull up since there's only one. But what I wanted to point out was the dependency graph. Or dependency graph is what I click on there. And you'll see there's this little message, no manifest found. That's something that we usually want to include with our software. And that's, there's quite a bit to it. We'll build up knowledge of it, but it's used in the same sense as the traditional usage of that word. Like a ship's manifest would tell the captain everything that was on the boat and why it was on that boat. We need that with our software. Right? So those couple things I just pointed at, matplotlib, whatever that prompt text was, colorama. If those are used in the software, we need something to tell any installers or installer packages that needs to be included, where to find it if it's not something obvious, why it's needed, and all of that information. So just like the software is a boat, and we need that list of everything that's going to be on the boat and why it is on the boat.
So Chris, is that where you would put the color, like you said, that if they need to install Colorama, that's where you would put that?
Yes, but we're going to install Colorama for them.
Oh, we install it for them.
Yes, we don't. Yeah, so it needs to be an automated process. That's why we have to handle it, because we don't want to trust our users just to be like, oh yeah, that's sure, that's on there, or have any idea of how to customize an environment, right? So we need to set up that as an automated process, and that's what the manifest does, as all the instructions for doing that. Which files to include, which files to not include, all the different layers. And on GitHub, if you go to Insights and Dependency Graph, if there's not a manifest, there's this little link here that links right to some really good reference material for different manifests, different forms, some of the most common formats. And in Python, there should be several Python ones. Carter did it. So pip is the default installer. You may have seen Anaconda and Voila as well. Those are just custom ones people have made. But since there is a default one in Python, those, at least those, especially those other two big ones, will work with that as well. So there's requirements.txt and pipfile.lock, and a couple others that we'll need in there. Usually projects.toml get included in a full manifest, and they're different formats. To start off with, I'm asked to include requirements.txt. That's the list of what I just pulled up on that like pip freeze thing. All the software that's used in ours that is not part of the default installation. If we use the print command, obviously we don't have to say you need to make sure the print command works, because that's in every single, you can't run Python without the print command. So if it's not included by default, we need to make sure it is. And pip is going to look for this file. So whenever we're ready to start making installers, where we just say pip install, in this case, pip install github.com Francis-Chris5 SDEV 220-spring 2023 / something on this repository. When we install it right from GitHub here, we need to have that pip needs to know what else needs installed, right? Like y'all may have seen that. Did y'all get Jupyter Notebooks installed or something? I can run it. I see head nods here in the classroom and on the video that's on. So it, whenever that was installing, it didn't just install that one piece of software, right? It said, before it installed that, it said checking dependencies, and then started downloading things and installing those. And then at the very end, it installed the one you actually asked for. So that list, that's what requirements.txt does. Pip will check that list and install anything that's not already there. So we need to include it. And if there's not anything to include, so like tonight's examples, just basic syntax pass, we're probably not going to import any modules to do that. We still need to include the manifest, because pip's going to look for that. And if it doesn't find it, if it doesn't find any part of a manifest, it's going to throw an error message and say there's no error, there's no manifest, it's not safe to install this. So even if it's a blank file, it still has to be required, be included. Which, so for module 1, it probably is going to look like that. What you're going to do, you're just going to have a blank text file and just go save that somewhere. It just has to have that specific name. Requirements.txt. So you can't, there has to be something with that name in all the code you submit, just to get used to that. You probably haven't seen it before, but eventually you'll get to the point where the installers will throw error messages if you don't see that. We'll see another one soon. We'll start with that one. There's also an init file. I'll add that in a couple weeks. And then initialization and some other things. And I wanted to point at this on GitHub because that's a good little semi-reference thing. You see how it shows the file types it needs. So if you don't know what one is, well, y'all know what to do with it. You can copy and paste from right there and just go Google whatever it is and learn about the different types of manifests. Some of the standards, that's obviously not all of them. And there's a lot of overlap. And we're programmers, we're the ones that tell the machine what to do, so we can customize that if we want to. But for now, make sure that requirements.txt file is there, as well as the bug report. Those are the bug report's 10% of the grade, and the manifest is going to be 10% of the grade. And before long, we're going to add the second part to the manifest. We might look briefly at the TOML file, but those are either real hard to generalize or they're the exact same every time. So it's either
Okay, Chris, so even if it's blank, I need to go in there and add that requirements.txt file for to my GitHub tonight. Okay, okay, thank you.
even if it's just a blank file, if I was to just instead of pulling from GitHub, if I was to use pip and install from GitHub, that would go in error. We're just going to pull from GitHub, so won't necessarily be doing that, but it does need to be included. Yes, that is fine. And I also asked, yeah, I put on there, please let me know which version of Python you're using, because things come and go. On week 1, basic syntax examples, there, or I guess that shows up in module 2, basic syntax. There's not really a whole lot coming and going on the basic syntax. That doesn't change much. Like, that was like the change between Python 2 and Python 3. But as we get into more interesting things, you might be pulling up some, might be using some more obscure features that either were removed in later versions or added in later versions. There were some major changes in 3.10 and 3.11, basically. Over the last 2 years, there have been some major changes. So if you're using major, like version 3.9 or 3.8, those changes wouldn't be included. And if I tried to run it on 3.11, it would, in a few weeks when we get to the really interesting stuff, you might need done something that doesn't run anymore. So make sure you let me know which one it is. But those two are together 20% of the assignment. And right now, they're probably as trivial as can be. Your dependency list is probably going to be blank and it's basic syntax, and everybody's seen Python before. So the bug report at most is going to say, oh, I made a typo. Issue, made typo. Solution, fix the typo, program ran fine. Issue closed or something. However you want to format that. But make sure you don't leave those two off. Let's see. Everybody able to get Jupyter notebooks installed? That one takes a little bit longer. We have to use the pip installer for that. So we use that quite a bit. Using GitHub, I guess I'll look at a couple things there. That seems like a good little next step. Last week we looked at the web interface. I'm pretty sure anything we do in this class is we can use the web interface for. You can just open up the browser, drag and drop your files there, or use that to upload and download them. But the name GitHub is because Git is actually an instruction we put in our terminals, in all of our terminals. So if I open up the thing, I'll be using PowerShell most often. From a few Zoom calls and stuff, I see some people still use command prompt, but just in case you didn't know, command prompt doesn't do anything anymore. All command prompt does is forward the command to PowerShell. Command prompt was removed from Windows and then people complain, so they put it back in, but it doesn't actually do anything except forward the instructions to PowerShell, and you can type the old command prompt instructions in PowerShell. So that seems to throw people off sometimes. I usually just use PowerShell, but it still works. People,
how do you get to PowerShell?
you can just search for it. What I usually do is if you hit Windows X, that pulls up all of your control commands, and PowerShell will probably be on the list. Or if you update to the new Windows terminal,
Oh, I see it. Okay.
if you see terminal on there, or when you can update to Windows terminal, this is one of those things that Microsoft did really well. Every once in a while, we see the things and get reminders of why Microsoft holds their place at the top of that software chain, because this one they just did really amazingly well. So I can run an Ubuntu machine and a couple of Ubuntu machines and a Kali Linux machine. Open up a bash terminal, run them all at once, have some things on the cloud, some things local. It's fully customizable. So you have complete control over what your terminal looks like in any system. So people who've worked with Linux, that's probably most likely a place y'all would have seen a bash shell. That's one of the things we're going to look at this evening. We have the customization level we can put on a bash shell on any terminal from any system. And we can set them up to run a Windows machine or remotely run other ones. The new Windows terminal is one of the nicest things Microsoft has ever put together.
Sorry.
Whenever you can update to that, it might be worth it. Sorry, was there a question? Oh, guess not. I thought I heard somebody say something while I was still talking. So that's what I use, and it has PowerShell, but again, it also has the old command prompt, which Microsoft actually removed several years ago, but then that caused all kinds of an uproar, especially from old people that have been programming since the 80s. Like, I know all the stuff from back from the days of DOS, and the old commands worked in PowerShell. They didn't delete anything, they extended it. I believe everybody's seen some object-oriented programming. You know the difference between deletion and extension, right? PowerShell inherited from command prompt. So what they did is they put something back in there that looks like it, but all this really does is send it to PowerShell. So might as well use PowerShell. That's the way I approach it. And PowerShell's kind of a nice language too. It has some really nice features. We're going to spend some time in terminal because we need that other control. This is our operating system control language. There's lots of different ones. The traditional Windows command or PowerShell updated that. It still uses the old one. They were the first to update to a modern scripting language. So like our loops and selection structures look like very similar to what we would type in Python. It's different. It uses curly braces, but not semicolons. And it's a loosely typed language, so we have to use $signs, but it's a modern language. It looks like what we would type in other places. It doesn't look like a programming language put together in the 70s, like bash and command, which it's for controlling an operating system. So it really doesn't matter which one we're on when it's going to be compiled to machine code for the machine we're on. So we can control any system with any one of the terminals. And when we install Git, we actually get something from there. For most of the semester, we'll be doing that from the terminal. We can do it there, but I wanted to look at another one tonight. So whenever you install it, the original Git, that's what I was actually going to type in there. Yeah. It's named because that is an instruction that we put in a command prompt. So if we just type the word in any command prompt, it was invented by Linus Torvalds as he was creating Linux. And it is spread everywhere in the world. It is spread as far as Linux has in our world. So no matter what command prompt you're in, you can type Git, and that's an instruction that the command prompt should know what to do with. I guess some systems might have old things not quite configured or have it blocked, so you have to manually turn it on. But that's where that name comes from. So we'll be doing that a lot of stuff in the terminal. There's a limited number of what we need, but it was created back when he was making Linux. Is that late 90s? Security was approached very, very differently than it is in the early 2020s here, right? Cybersecurity wasn't even really a word back then. There might have been a couple people in the world that knew that word. Most of us did not know that word. So security levels have improved. So that old one, the one that's going to be built into all of your terminals, command prompts, and shells, and all of that, has the old stuff, late 1990s level security. Okay, this will fix that. That's the setting. It's manually turned off for some reason on your machine if you don't see it. If you just go to Google and download Git, the top result should be this Git SCM. So if you just hit that and download the appropriate version for your system and run the installer, that will take care of everything. Just accept all the defaults are fine. Especially on this, since this is something specifically for programmers, as you go through the installer wizard, you'll see all kinds of options for new features. And sometimes, and it changes. So sometimes you might see things like things in official release, alpha release, beta release, and multiple versions. And like, yeah, here's a future thing that might be coming, and they just release it to lots of different versions. But if you just accept the defaults all the way through, it should be good. Just download Git or gitscm.com, and that will bring your system up to the current one, which one of the biggest advantages, as far as the noticeable one for what we do day to day, is you won't have to type in a password every time. This passwords are outdated, because even if you type in the password, you get an error message that says passwords are going to stop working at a previous date. So it was already supposed to stop working, but they haven't actually flipped the switch yet. So you'll notice like passwords are going to stop working, and then you'll see a date that's like 9 months ago now. So it could completely stop at any time. Otherwise, you have to use tokens and stuff. We'll see that somewhere. We want to download that, and with it comes other software. When you run the installer, there's a bash shell configured to run Windows. So if you just like using bash, you use Linux a lot and get confused every time you go back over to a Windows machine. This is configured for Windows, so you can just use the bash stuff to run Windows. That comes with it. There's also a GUI. That's the one I wanted to look at next. So the GUI has some nice little features, some drag and drop stuff. So when we make changes, we can connect to our repository. There's one feature on the Git GUI that I think is the best view of any of them to see it. Obviously, we technically have the same controls everywhere, but they're going to be formatted slightly different. And when we do something in a terminal, it's going to look like a terminal. On the web page, there's a style sheet and things are laid out kind of nicely, but sometimes it gets cluttered. So what we need to do is we want to work with our existing repository. So I'm going to clone a existing repository, which I clicked the wrong button. I'm going to go back to GitHub and
Okay, I was able to download, install the Git, and then how did you get to the GUI?
After you download it and run that installer, there's three pieces of software that download it. So there's a Git bash shell, and there's also a Git command. So you have the Windows command prompt that'll run a Linux or a Mac machine if you're just used to those commands. But when you start, after it downloads and installs, that application will be on your computer. So you go to Git GUI, and we can create a new repository here or clone existing repository. Okay, this is updated since the last time I looked at it. That's why I thought I clicked the wrong button. So the source location is our repository here. So if I come over here and grab the repository for this class. You can click the green button that says code and copy the code, which on your repository, you probably know the address for. The one thing you want to make sure of is what I pointed out earlier, that it's not the web address URL. It has that .git extension at the end. So when you have that address, paste that in as the source. And then we'll browse to where we're going to make a copy of that. Which most of your IDEs have this built in as well. I'm probably not going to cover that, but yeah, most of your text editors and IDEs can directly access GitHub as well. And other repositories. Depends on which one you're using. Some of them have more than others. Some of them are fully customizable. Some of them made by Microsoft can only access GitHub, which Microsoft also owns because it's Microsoft. And just like they do with Outlook email, they're going to act like no other versions exist anywhere in the world. But there's different ones, and it's slightly different. But somewhere in your text editor and IDE, you will have buttons or configuration controls to set it up there. So when you go to store it, you want to go to the parent directory. This is what's a little bit different than software you might be used to. Go to the parent directory and select that folder. But then we have to add another folder name. But the GUI has to create that other folder. So after you select the parent directory from clicking around like normal, then add in some other folder name. I'll call it Git stuff. And the defaults are okay for now. We'll clone this, so it'll grab that. And here's what the GUI looks like. If I come over to the File Explorer, you can see it created that folder and then grabbed all those files right from the repository. And when we're done, we'll push things. When we're ready, we'll push things back up there. If you like working with GUIs, it's nice and organized. One thing I really like about this one, and something now often ends up being the only thing I use it for, is I think this has the best version of the history. We can get to it from anywhere. Obviously, the terminal, go to the website, anything we're accessing GitHub, we can get to that history. But well, we're in a classroom setting, we're in a learning setting, so I'm going to suggest trying all the different ones. The website's easy to use. Maybe this first week, try the GUI, and then next week, try the terminal, and try different ones, experiment. The week after that, try the one built into your IDE. Click different buttons. You all know how to try.
Sorry to be so needy, but can you help me if I share my screen? I don't know if I clicked on the right Git GUI. I mean, I have the Git GUI, but I don't know if I clicked on like new repository. Is that what I needed to click on? New repository?
I cloned a repository.
Oh, okay. I'm sorry, go ahead.
Existing one. I almost always use the web browser to create a new one because I think that has the best versions to create stuff. And we can create new ones anywhere and name branches and stuff. They all have different advantages and disadvantages. There's different buttons you're going to want to click around and look at things, but this the history here, so view all the branches history. I think the GUI has the best version of the history. Everything you see here is clickable. So we can go back and click through anything on here and see all the different options. So there's some notebook file. See the times when every upload happened, what was in that upload. All we did was additions, so it's all green right now. We get that color coding that's missing in our terminal where some of it's green, some of it's red. You can look at different ones, right? Look at the difference. We'll have green and red side by side, and it'll have plus signs or minus signs showing what we added or took away. Look at the old version, the new version, adjust how many lines you're looking at a time. And basically everything here is clickable. That's why I really like this. So if I'm going to history, I usually open up the Git GUI and go here for the history instead of trying to read it from a terminal. Because you don't know what that's like when there's a whole lot of stuff in our terminal, our eyes are going to get blurry before we get to the end of it. We need something to upload here. Let's get started with the example. Say I used Spider last time. I used Notebook tonight because just want to use those occasionally. So for that, we do have to start from a terminal. So I usually hit Windows X, and on mine, I is terminal. That gets all the command features. You might have to look to see which letters underline on your particular system. If you have it set to open command prompt by default, or PowerShell, or maybe you have a bash shell set to be the default. So if we want to work with a notebook, well, just in case anybody didn't get installed, to install it, it's just pip install notebook. And you run that, it'll download all the files it needs, anything that's missing, because Jupyter Notebooks has that requirements txt file like we were talking about, so it can look at that list and figure out what's there, what's missing, what has the wrong version, if it's a greater than or less than situation instead of just equals. Can do all that, and then when we're ready to open it, like Jupyter Notebook. And then that starts up a little virtual server. So you can see there's still sort of a server running in the background. May get some error messages back here, so remember to check that occasionally before, make sure there's no error messages that are going to escalate into something big later. That's going to be a big one. That's more likely to happen when we get to Django, which will have a different type of virtual server running. But it's really easy to overlook, to not notice the small error messages in the background. And then at some point later, there'll be a huge crash. You can't figure out why, because nothing you can see has any problems. And then when you start closing out of things, you'll see there's just this huge list of error messages in the background that you forgot to check. At least I know how that happens to me, has happened to me more than once. So remember to check that whenever there's stuff still running there. And then you'll choose a place to run it. Microsoft recently changed some things. So a lot of you, depending on when your system was set up, you might not have a local desktop anymore. Or your documents folder might be the one on OneDrive. They do that, it's automatically backed up, it's really safe and secure, but it causes problems because then that's not the same documents folder we go to from PowerShell or command prompt. So it gets confusing. If you want to change that, let me know and we'll go over it sometime. You do have to actually go into the registry and change that. I'm pretty sure before long, we're going to have to do that if we want to use Google Chrome instead of Edge, or Chrome or Edge, Firefox instead of Edge, because they keep adding things. The latest version, you have to go through every single file type and say use Google Chrome for that to prevent using Edge. But they started doing that with folders, which makes a lot of sense. Your stuff's backed up. Or you get another computer, log into your Microsoft account, and then you still have your old desktop there. you don't have to spend a bunch of time reconfiguring things. But for me, where I'm constantly breaking machines on purpose, so I can show you all how to fix them, and resetting my computer after every course, because I'll just break things on the way through the course so y'all can see what breaks the machine, so I know how to fix it. If you haven't had me in class before, we'll see a lot of that. I like to throw the error messages so we can see it and how to fix it, instead of just telling you all to avoid it. I think that's a little bit more useful, knowing how to actually fix it, than hoping you'll randomly remember to avoid it. So if we go and delete, I can change one of these. Go and get stuff. And only one of these was working, wasn't it? Okay, first class exam. So nice about some syntax. So we saw some math stuff. We saw regular assignments, brought the emoji, went in. I saw a couple people said they had trouble with the emojis. Did you all get that to work?
Not all of them, but
Yeah, if you go, there's two lists. So there's one list that goes to their GitHub, and that has all the ones they included. But then they also included the one to the actual official Unicode list, and they didn't include everything from there. So they don't all work. You have to try around, see which different ones work. But I moved that to week 1 because emojis are part of the English language, right? I get those all day long in professional emails. It's part of our language. So as programmers, we probably need to know how to output that sooner rather than later. Some basic math. We have X and Y there. So we can set up things like X plus Y, or run that. Oh, notice it gave an error. You'll see this a lot in notebooks. Does anybody see what the error is? I'll let you stare at the screen for a second.
You didn't define the variable, or X says X isn't defined.
Oh, but we can see it defined. It's 3 cells up.
Oh,
No, it's not. The way Jupyter works, it's not the same in the same thing.
Yes. So this number right here, right, Kyle?
Yes.
If the number this says that cell I just ran was run number 1. But if we have another run number 1 above from last week. So it's still remembered that cell was ran, but we haven't ran it this time. So it doesn't know about that. If I go back and hit cell, run all. So yeah, make sure you look at these run numbers, because that will get you off as well. If you're used to just doing everything in one long file, you make a change, you're running that whole file again. But if you make a change 3 cells up and then go back to the bottom, you need to make sure there's nothing in between there that needs to rerun as well. So there is a run all button. You can come up and run all the cells, and now it's defined. And notice that it's just like the terminal. If we just put the math right there, it just spits it out automatically. It's better form to put print there, so that we still get the output even if we make changes to it later. Or even better form to save it somewhere.
okay. So you and Kyle are saying that error
Oops.
was there because it only ran that single cell?
Yes.
Okay.
Yes. Notice the numbers now. So now we have 2, 3, 4, and then run 5. Because I accidentally ran this a second ago. I accidentally hit the keyboard shortcut to enter start a cell above. Which one is the? I don't think that's even in the menu. I think Alt A does that. I accidentally bumped it, but it's not one that I do very often. We can drag these around, I think. Oh, wait. In Google Colab, we can drag them around. If we're in an actual notebook, we have to use the arrow to move them up and down. But yeah, pay attention to those numbers, which output it is, which input. Now if I run that cell, hit Control Enter, we don't get any output because we haven't done anything with it yet. But we can do some stuff later. Our basic math syntax, I think everybody's seen this before, right? X times Y, C is X, integer divided by Y. Let's see, run that. So 2 slashes gives us integer division, and 1 slash gives us floating point division. I'll make this D. D and then C equals X divided by Y. So when I run that cell, we get the floating point number like we're used to from a calculator. 2 slashes for integer division. Integer division, just in case you haven't seen that. Floating point division. And to go along with floating point, we use integer division when we want quotient and remainder and get the exact form instead of the decimal form. Because usually, quite often, we will run out of digits on decimals. Sometimes strange things will happen. I always give the question in 140. Did anybody see in 140 class where you were given a sales tax assignment with something that looked an awful lot like Indiana sales tax numbers? And your rounding was always wrong if you put in $1. A lot of numbers worked out fine, but if you put in $1, it would round incorrectly. That's because we only have so many bits, and it did not come out to a perfect 1.07 in the 32 bits we had to represent that number. So the difference between binary representation and decimal representation will sometimes show up. So having exact values can be useful. Then we can keep fractions around till the very end and deal with those afterwards. Or there's lots of versions for that. Modulus operator. But usually the integer division and modulus, we use those together to get quotient and remainder. I'm pretty sure there's something of that in the assignment. Surely there is on the basic syntax review. All that look familiar, storing variables. Let me add a markup cell here. Switch this to a markdown cell.
So is there a way, like if you wanted
And
the floating point, that where you can just make it 2 decimal places instead of like a 13 point?
Oh, formatting. We will see formatting soon. We're going to go on at length about formatting.
Okay.
There's lots of ways to format things. And it can be a bit tedious. So we'll look at several ways to format it. But yeah, if you don't know how to format it already, don't worry about that for this week's assignment. When we get to strings, we're going to spend a while looking at formatting numbers. Probably at least 35, 45, between 35 and 45 minutes that night. It's not like there's not one way to format numbers. There are lots and lots and lots of ways before we even get into external libraries where people have made better ways to format numbers that we have to import the library in order to do. So we're going to spend a while on that, but great point, Dave. So Control Enter runs the current cell, and Alt Enter runs the current cell and then creates another cell afterwards. Selection structures, that's something we might need to do, right? And I believe everybody has seen these before. That's why we're just going to kind of rush through it fairly quickly tonight. Might do some more stuff after a break, but I'm gonna quickly do selection structures and loops just to get this knocked out and then get back to the GitHub repository stuff. Because that one might be a little bit newer than the basic syntax of Python. So we have some numbers. If A is greater than B, then a colon, and we indent some stuff, right? So print the sum is bigger. Whoops. Better put some quote marks on there. Sum is bigger. Then we undo the indenting, and if you worked with a lot of other languages, most other languages, our middle point would be else if, which is a shortcut for nested if statements. But in Python, white space matters. So we can't have a two-part keyword. So in Python, which I'm pretty sure everybody's seen before, we abbreviate the elif part. Elif A is equal to B. Print sum and product are the same. And then after, we can have a whole bunch of elifs, condition beside each one. Oftentimes when I'm writing code, I will do just if and then elifs, and that way I have control over every situation. But a lot of time we do have a default option. After we do all those, we can just do the else. Since none of the conditions were met, this is what to do if nothing else works. If none of the above conditions were true. So we did greater, equal, the only one left would be less than. So that would mean the sum is smaller than the product, or the product is bigger. Print product is bigger. And we can check a few numbers to see what sort of pattern it would take to get our product, our sum to be bigger than the product, or where that change happens. Right? 3 times 4, or 3 plus 4, multiplication's bigger. So smaller numbers might work. 3 and 2. Again, if I run this, if I run it now, that thing we looked at earlier, this is all the way up to run 12. So the next one's going to be 13. But our X and Y numbers, where we store those values, is still on run 2. So we need to rerun this one first. Rerun that. And now the next run of this cell will be afterwards. So when you start working with notebooks, you will need to watch out for that. It's an extra step in debugging. Just make sure to keep an eye on those numbers, which what order they were ran in. That one didn't work, but make one more change here. This one should be, that one should give us a different condition, right? 2 times 1 is 2. 2 plus 1 is 3. So the sum should be bigger this time. So if we run that cell, we can see the number there, and we come back down, run the condition, and it sort of categorizes our code. So we can see different parts. It also runs quicker. With a notebook, we are running compiled Python. If you hadn't seen it before, like when you make objects or when you import one of your Python scripts into a new Python script, it automatically creates that folder PyCache. Everybody seen that folder before? Gone in there and look at what's in there. Python is both interpreted or a compiled language. So the PyCache is for compiled versions of it. So which run obviously quicker than an interpreted language. Interpreted is line by line. We take line 1, turn that into bytecode, which the machine can make sense of, and then run that. Then we come back and get line 2 and do that. Whereas compiled is we take the whole file, turn that into some sort of machine language, usually bytecode. For Python, it goes to bytecode, and then the bytecode can be translated to machine language right at runtime. But we turn the entire file into something the machine can work with all at once. And one way to think about notebooks is each one of these cells is a different .py script. So like what's up here in the top cell, we'll run that. And then in the cells below it, if I go hit the run all button, so run all, that way our numbers are all in order. Cell 17 ran there, which stored those things in variables, but it turned that into compiled Python. And then in cell, the next cell down, which looks like run 18, it automatically imported that. So that's when it compiled it. So with notebooks, we are running compiled Python, which is a little bit quicker. We're not going to notice it in tonight's example where we're looking at basic syntax, but when you get to really, really, really big things, that little bit quicker adds up. That's one advantage. That's also, there's organization, there's a speed advantage, but the speed advantage is kind of negated by human speed, needing to go back and forth and choose which cell to run and hit manually run each one. So the speed advantage is quite often overridden by the organization thing. The organization is the big thing. That makes sense. Variables, math, selection structures. And here I'll point out on the selection structure, there's sort of a format. We have a keyword, something the Python interpreter knows about. Then we have something unique to our situation. Right? There's going to be a different one than that every single selection structure we do. That part's different. Our keyword's always the same. Then we have a colon. And then we indent the stuff that goes with that. So keyword, something unique to our current situation, a colon, and then indent all the stuff that goes with it. That's what I think of as the basic Python syntax. We will see over and over again. So for like loops, I'll go with the bigger one where the product's bigger. What was it? 3 and 4, which will get us back to where that product's bigger. And while A, which is the sum, is less than B, then we want to take X minus equals 0.1 and Y minus equals 0.1. We'll subtract 0.1 from both of them and then print out what that is. Print, let's see, A plus B, A times B, and then we'll find what they are. A equals X plus Y, B equals X times Y. So kind of repeating all that stuff, we'll print out. Really, it would probably make a lot more sense if I did this down here, right? We print it out and then we make the change instead of make half the change, print out the old version, and then find the new version. I'll switch that around to systematic things. We all have seen that. And for those who haven't seen me in class before, starting off with nice slow examples so you can get used to me changing my mind. I usually practice lectures ahead of time and then constantly change my mind when I get in here. It happens a lot. And the examples will get faster and faster and faster. Part of going slow at the beginning is to get used to me and how I go through things. And I'm usually easily distracted. So nothing happened that time. So, well, it's line 17, but we haven't updated that. I need to go back up here. The thing with notebooks, I remember to do that. Run this cell, we see the sum is bigger. And that's not right. Whoops. Leave that cell. Cut that cell out of there. cell, run all cells. There we go. So got back to product is bigger. So the run all button is very, very useful to avoid that. Just run everything all at once. But as your things get larger, that might be completely unfeasible. Like when we get to the data analytics thing, and if anybody looked ahead at the one we actually have to do, Lab 5, and noticed that Amazon gave you an 8-hour budget for that, you're like, what? It's an 8-hour homework assignment. You're not going to be writing code for 8 hours. You're writing code for about half an hour, and then you're going to leave and go get lunch and go do some other stuff, and it will hopefully be finished when you get back. And one of those things. For that, running all the cells above would not be feasible because you don't want to accidentally run one of the really big cells again. Okay, if there's a cell you have to wait for an hour and a half for it to run, you definitely don't want to use the run all button. That can be a bit catastrophic. So practice it both ways. And we see it going down. I guess I probably should have printed what X and Y were to figure out the point where we get something that the sum or where that transition happens. The assignment operators, everybody seen those before? Just in case you haven't seen it, X in this case equals X minus 0.1 is such a common thing to happen that we have an abbreviation for it. That's one of our most common operations, an accumulation or decumulation, increment and decrement. It works with all of our operations. I was about to make a more complicated note that we will see in about 4 weeks. Even when those operations get very, very advanced, we have that shortcut. This is another thing about writing code versus running code. With that written out the long way, that line is written left to right. We read that left to right. X is assigned X plus or X minus 0.1. But the fact that that line works indicates that the code runs right to left. Because everybody looks at that, you know, this is the old value of X, right? Otherwise, we'd have an infinite loop. So what's in the text file is not the same as what goes through the machine. That make a difference. That's what computer scientists study. That's their research project, right? Put together a big experiment to figure out what is the best way to do that, the most efficient way, and the difference. This is software development. This is in computer science. We're looking for code that works. Not necessarily, it doesn't necessarily have to be the best possible way that it can be done. We just want it to work. But I always like to point out that line. The fact that this code works shows that our instructions actually run right to left. There's some other details we'll get into later. So that brought almost 7:15. That's what time I was thinking about for the break. That's what I'm usually gonna plan for. And then afterwards it's gonna be a shorter section. Before everything went to 8 weeks, it was 2 hour and 15-minute classes. So an hour and 15 minutes seems like a good time to shoot for a break, maybe sometimes an hour, depending on when a good stopping point is. But real quick before we go over to back to the other thing, here's that same thing again. So we have a keyword, something unique to our situation, a colon, and then we indent everything under. Anybody have any questions about the basic syntax? Hopefully that all looks very familiar, right? Everybody seen that before? So it should be good. So I'll go up here. Notice there's not a save button. There's make a copy, save as, and it's because it's a Python thing. We have to save it before we ran it. We've already run everything. So if you ever need to make that line just to check, again, depending on the program you're doing, like in data analytics or machine learning, you would definitely want to avoid the run all button. But for something small, like your homework assignments, you can just do run all one more time because we have to save it before we run it, and that confirms everything's been saved there. So now I should be able to close out of this. Can go back over here and confirm that that was saved. It doesn't show, oh, that's not it. This one, 17. So yeah, saved 1 minute ago. I was looking at the wrong file. That really should not be set to open with notebook. Can I reset that? I don't think I can just turn that off either. And notice the notebook is actually a big JSON file. So it's not even Python, it's actually JSON that JSON, but then we yeah, it's actually JSON. It's not Python. We just type Python and then it's JSON code. We can look at those details later, but it looks like that's we made those changes. It's still in that repository thing. So I can come over here and notice the buttons all go right in order. So if I rescan the repository, it says there was a change to that IPYN by the notebook file, IPYNB I Python notebook. Over here, it'll show us the change. So execution count was 1, but now it's been run 32 times. This one, we see the changes in the JSON format. So it's kind of a little difficult to tell, but we know it all worked and stuff. When it gets back on the web, we'll be able to preview the file. Like, okay, those changes look good. And the next thing down, so unstaged changes, they use terminology like backstage and on stage, that sort of thing. Baseball terminology, I think might have fit better. The on deck versus the batter. We need to move that up. So it's like all those changes look good. So move to stages changed and confirm, yes, there's one file that was changed. So what? Get index failed. Okay, I'm not sure why that failed. I just said can unlock it. I don't know why there was something locked on there. Nor do I know even, I don't even know which file was locked. Some file called index was locked. But for whatever reason, after you get stage changed, move down here. Then we need to put off some sort of a message on it. So a message, there's 2 versions. There's a short version and a long version. On the GitHub, when you do the on the website, when you do the upload, there's a short box and a big box, and if you leave them blank, it says change by file upload. We'll see it in the command prompt what we do there. So the short message, and that one actually turns into a link that we can click on the website or any place else. Will turn into a link on the history thing over here. All of that. It goes on one line. So second class session. A short message on one line, then skip a line, and then a more detailed message. So like everything after you skip one line, even if you do 5 paragraphs, that all becomes the long detailed message. The basic is at Python syntax. Example in class. So a longer message, short message and a long message. And the short message will become a link that you can click to around your repository. So that looks good. So sign off on that. Oh, I haven't signed in to GitHub yet. We're going to do that here. Yes, all the examples from class will be in the GitHub repository. I'm not sure where the sign off button is on this, so. Once all that's ready, then you can commit and push it back to the thing. But I need to look up where that button is, and it's almost time for a break, so I'll have to look that up later or jump over to the terminal and do it during the break, and then we can finish this out. But it just walks down right down the buttons. You're gonna want to play around with it. The main thing I wanted to look at was that this was here. But it's probably a good time to take a 10-minute break, right? And I will look and see where I sign in on the GUI because I've never signed in on the GUI. I'm used to doing this in the terminal, but I just did a factory reset on my computer before the semester started. Apparently I haven't done anything on GitHub since then. So I think I will, over the break, I'll just go sign in where I know how to do it on the terminal with a different repository or something. So then and then we'll hit the push button after a break. Does 10 minutes sound good to everybody? You don't need to see me enter usernames and passwords, right? We can do that. I can do that during the break, and then we'll hit those last couple buttons afterwards. So my laptop says 7:16, so we'll get back to it at 7:26.